This video is going to show how you can graph a quadratic function on a coordinate plane. So, in example 1, here I have a quadratic function. How do I know it's a quadratic function? It's got a degree of 2. So I have y equals x squared minus 6x plus 4. Now, in order to graph a quadratic, quadratics are parabola shaped, so they either open upward or they open downward. So upward here, or they open downward. I need to find the turning point. That's the most important point there, because then I have to find a point on each side of the vertex, which is also known as our turning point here. To find that point, I'm going to use the formula x equals negative b divided by 2a. And when we look at quadratic in standard form, here's our a. So our a, b, and c are going to be our coefficients. So a, b, and c. So I take the opposite of my b. So if my b is negative 6, I would do a negative 6 divided by 2, and my a in this case is 1. So when I do that, I have 6 divided by 2, which is 3. So on my coordinate plane, I'm going to draw my vertex at x equaling 3. So here's my vertex, or my axis of symmetry, I mean. So I'm finding the axis of symmetry, which is x equaling negative b divided by 2a. Now the vertex is going to be somewhere on that line. So to find where on that line it is, I'm going to put 3 in for x to find my y. So now I have 3 squared minus 6 times 3 plus 4. And my y coordinate is going to be 3 squared is 9, minus 18 is negative 9. Negative 9 plus 4 is a negative 5. So I have a point, my vertex is going to be at 3, negative 5. So 3, negative 5 would be right here. So this is the turning point. Now I know it's going to open upward. How do I know it's going to open upward? Because my a is a positive. Now determine another point. You can there's multiple ways of doing this. You could pick a number on an x coordinate on each side of the vertex and plug it in for x, or you can use our c, which is our y-intercept, because when x is 0, y is going to, all we have left is our y coordinate. So when x is 0, y is going to be 4. So I have a point at 0, 4. So I have a point here. And then since I have an axis of symmetry, I can mirror that point. Since it's 3 steps to the left of the axis of symmetry, I can go 3 steps to the right and plot a point there. As long as I have 3 points that makes a parabola shape, I can now graph that and draw my lines. So it comes down here, comes up, and there's my parabola. Example 2, graph this quadratic function. Okay, we're going to find the axis of symmetry again. So I have x equaling the opposite of my b. My b this time is 4 divided by 2, and my a is a negative 1. So a negative 4 divided by negative 2 is a positive 2. So my axis of symmetry is at a positive 2. So there's my axis of symmetry. Now I want to plug in my 2 in for x to find my y. So I have y equals a negative, and then I have 2 squared plus 4 times 2 plus 1. So 2 squared is 4 times a negative 1 is negative 4. Negative 4 plus 8 is 4. 4 plus 1 is 5. So the vertex is at 2, 5. So I put a point at 2, 5. Now you'll notice that there's a negative in front. That means it's going to open downward. So that means I'm going to choose a point. Again, you can choose a number on each side of the axis of symmetry. I'm just going to keep it basic and use our C, which is 1. So that's my y-intercept. So I have a point at 0, 1. And it's 2 steps to the left of the axis. So if I go 2 steps to the right of the axis, I have my other point, and I just need a minimum of 3 points with 1 point on each side of the vertex. And then I can draw the parabola. And there's the graph of this quadratic function. And our third example, here you can see that our middle term, our b, is missing. So how would we go about graphing this one? Well, I would do the same thing, x equaling my b, which is 0 because I don't have it there, divided by 2a, which is 3. So a negative 0 divided by 6 is going to be 0. So my axis of symmetry is going to be my y-axis. So if I draw my axis of symmetry there, and now I need to plug the 0 in for x. If I put 0 in for x, my vertex is going to be at negative 2, 0, negative 2. So my vertex and my y-axis is the same. So I'm going to put a point here at negative 2. Now I have to choose a number on each side. So I'm going to just keep it simple. I'm going to put a 1 in for x. So what is y when x is 1? 1 squared is 1 times 3 is 3. 3 minus 2 is 1. So I have a point at 1, 1, 1. And then if I have y equals 3 times negative 1 squared minus 2, if I put a negative 1 in there, negative 1 squared is 1. 1 times 3 is 3. 3 minus 2 is 1. So now I have a point at 1, 1. And I have a point at negative 1, 1. And now I can draw my parabola. And there's our parabola. Now just keep in mind when the b term is missing, you know that you have your axis of symmetry is going to be the y-axis, and you'll have to pick another point because the y-axis, or your y-intercept and your vertex are going to be the same point. So that's how you can graph quadratic functions on a coordinate plane.